Enhancing applications with object storage. In this video presentation, you will learn about object storage services in general and the services available in Bluemix. Topics that will be covered will include the Bluemix Platform as a Service Catalog Object Storage Service, OpenStack Swift Object Storage Architecture, Swift Object Storage API Essentials, and Cloud Object Storage services available from IBM Bluemix Infrastructure. Among the many cloud services cloud computing provides, object storage has arguably experienced the most growth in recent years. But what exactly is object storage? Object storage is an electronic storage that is highly scalable, easy to use, cost-effective, having huge capacity, and implemented with a distributed system expanded across regions and even countries. It is commonly used for storing pictures, documents, audio, video, system backups, and database dumps. Object storage has become a backbone service in cloud computing. Cloud service providers each have a variant of object storage available today, and there's some variation in terminology, but they all have common characteristics. People can confuse object storage with other common systems that store information. A database is not considered object storage. A database cares very much about the data and the data structure saved in the database, and designing a schema for the data to be saved in a database is probably the most critical task a database application designer has to do. However, for object storage application designers, data structure is less important. Object storage doesn't require structured data. Block storage can provide raw disk space for client applications to create file systems on and then store data in that file system. In this case, the application is very much in the business of managing the file system. However, object storage for a client application does not really care about the underlying file system. Client applications require only that an object is sent to the object storage and persisted for later use. Object storage differs from file systems in a few ways. First, object storage often has a flat structure. An application can create a container and then place an object inside the container. File system, on the other hand, can allow unlimited container nesting. That is, you can create many levels of containers or folders. Second, the method to manipulate objects in an object storage is an HTTP request with REST, supporting create, retrieve, update, and delete. The method to manage objects in a file system is local. That is, applications typically use language libraries to manipulate files through local system calls. Unlike typical file system models, the data in object storage is maintained in multiple copies to provide higher availability and to minimize the risks of data loss. In addition to traditional enterprise-class storage technology, many organizations now have a variety of storage needs with varying performance and price requirements. OpenStack has support for both object storage and block storage in the cloud, with many deployment options for each depending on the use case. The OpenStack object storage platform is called Swift. Let's talk a little bit about a common issue in storage. The CAP theorem identifies three distinct concerns. The first is consistency, and that is, all clients see the same data even with concurrent updates. The second is availability. All clients are able to access some version of the data. And the third is partition tolerance. The data can be split over multiple servers. The CAP theorem states that you can only have two of these three available in any distributed system. OpenStack Swift sacrifices consistency for availability and partition tolerance. Most operations happen synchronously, but consistency is sacrificed in failure scenarios. Like object storage systems in general, Swift storage uses containers to group files. They are much like folders in traditional file systems but cannot be nested. Swift is accessed by using a REST API that uses HTTP verbs, get, put, and delete. And Swift can be built out on scalable commodity x86 hardware, making it very cost-effective. IBM Bluemix provides different offerings for object storage for different needs. The Bluemix Platform as a Service catalog includes object storage services that can be easily used with Cloud Foundry applications running in each Bluemix public region. The Cloud Object Storage offering from Bluemix Infrastructure provides more flexibility in deployment model and options for geographic control of data location. The object storage service in IBM Bluemix Platform as a Service catalog is based on OpenStack Swift. To access the service, an application must first obtain a token through authentication using Keystone, which is the OpenStack identity service. Using this token, the application then uses the Swift API to manage containers and objects. When using the Swift API, containers define our namespace for objects. An object with the same name in two different containers represents two different objects. And you can create any number of containers within an account. Developers can manage metadata associated with containers through the Swift API. In addition to containing objects, you can also use the container to control access to objects by using an access control list, which is part of the metadata. You cannot store an ACL or access control list with individual objects. Objects store the data content, such as documents, images, and so on. You can also store custom metadata with an object. The Swift object storage architecture provides separate access and capacity tiers that can be scaled separately. The access tier can be scaled for greater concurrency. It is a stateless, shared nothing architecture. The capacity tier handles the actual storage of objects and can be scaled out for greater capacity. Uploads are routed through the load balancer through to the capacity tier, where multiple copies of the object are written for redundancy. Downloads are also routed through the load balancer that direct the request to a single copy of the object in the capacity tier. One of the hard problems that needs to be solved in a distributed storage system is to figure out how to effectively place the data in the storage cluster. Swift has a unique as possible placement algorithm that ensures that data is placed efficiently and with as much protection from hardware failure as possible. Swift places data into distinct availability zones to ensure both high durability and high availability. An availability zone is a distinct set of physical hardware with unique failure mode isolation. In a large deployment, availability zones can be defined as unique facilities in a large data center campus. In a single data center deployment, the availability zones can be unique disks in a single node cluster running in unique rooms that are separated by firewalls and powered with different utility providers. A multi-rack cluster might have availability zones as a rack and everything behind a single top-of-rack switch. With Swift, you can choose how to define availability zones based on the particular details of the available infrastructure. In managed cloud services, like IBM Bluemix Available Services, these decisions are made for you, but the technical trade-offs in these decisions form the basis for the different services available from IBM. Here's an example of using an API of the object storage service to authenticate with Keystone. You'll get an opportunity to do this in the hands-on lab. If the object storage service is bound to an application, you can get the credentials from VCAP services. Or if unbound, create a set of keys and copy the user ID, password, and project from the keys. To authenticate, use a POST request to the authentication URL endpoint as shown using curl or a REST library in your program. Successful authentication will return a URL endpoint for accessing the service and a bearer token for subsequent Swift API calls. Here's an example of a response from a successful authentication. It includes an X subject token header, and the response body includes public interface URLs for accessing the object storage service. Append the URL provided with the appropriate container name and object name as shown to invoke the Swift APIs. Use the value for X subject token as the authentication for calls to the Swift API. Let's quickly go through some of the API operations for containers and objects. First is creating a container. Creating containers is done with an HTTP put. The storage URL and auth token returned from the authentication operation are used in the put operation, and that includes a container name. A 201 HTTP code is returned on success. Container metadata is returned by using the HTTP head. The storage URL and auth token returned from the authentication operation are used in the head operation, includes the container name. An HTTP 204 code, no content, is returned on success, and the metadata is returned in the HTTP header. Here's an example of uploading an object. Uploading objects are done using HTTP put. The storage URL and the auth token returned from the authentication operation are used in the put operation that also includes the container name of the URL followed by the file name. The contents of the file are included in the request body. A 201 HTTP code is returned on success. Listing containers is done with an HTTP GET. Again, you provide the URL followed by the container name. If you use the format equals XML or format equals JSON query parameter, the response shows extended container information serialized in the specified format. If you append the format equals plain query parameter or don't use a format parameter at all, the response lists only objects separated by new lines. Downloading files is done by using an HTTP GET. Provide the URL, container name, and object name in the request. The contents of the file are returned if the request is successful. Deleting files is done by using an HTTP delete. Again, provide the URL, container name, and file name. An HTTP 204 code is returned on success. IBM has some new cloud object storage services based upon the IBM CleverSafe acquisition. These services provide some encryption of data in flight and at rest. There are some trade-offs in performance versus availability, in addition to interface for access to the current Bluemix infrastructure cloud object storage services. The cross-region service provides the highest availability at a small impact to performance by placing copies of the objects across multiple data centers. The regional service places all copies within the same region, which can make access more uniform and also provides more granular control of data location for any regulatory reasons. The three regions used by the IBM Cloud Object Storage Cross-Region Service are Dallas, San Jose, and Washington, D.C. at the current time. It supports access through an S3 API. It provides high durability and availability with a small cost on higher latency. The Cloud Object Storage Regional Service, in this service, information is stored and located in one of 20 global data centers. It's accessible through a Swift API. This service does not currently provide encryption at rest. Both of these services can be managed through the IBM Bluemix Infrastructure Control portal. This concludes our presentation on object storage services. Thanks for listening.